Hi sa akong mga pre-calculus students. We are now in topic 18 of quarter 2, which talk about trigonometric equations. At the end of this lesson, you are expected to solve trigonometric equations and solve situational problems involving trigonometric equations. We have already learned about equations in our previous lessons. We differentiated an identity from a conditional equation. Recall that an identity is an equation that is true for all values of the variable in the domain of the equation, while the conditional is an equation that is not an identity. In this lesson, we mostly study conditional trigonometric equations. We divide the lesson into two groups of equations, the ones using a basic way of solving and those using more advanced techniques. So in any equation that involves trigonometric equations, it is called a trigonometric equation. Recall that a solution or a root of an equation is a number in the domain of the equation that, when substituted to the variable, make the equation true. The set of all solutions of an equation is called the solution set of the equation. So let us now proceed to answering equations with one term. So let's proceed to example 3.8.2. But before that, let me first read the different simple techniques involved at least one of the following ideas. So first thing to do when you solve equation, equivalent equations atong banda dyan, that is equations that have the same solutions as the original equation. Nga ipaparehas mo ng ato ng banda dyan. Next is periodicity of the trigonometric functions involved. So na period. Then inverse trigonometric function, values of the trigonometric function involved on the interval given. And lastly, we have to use the zero factor law. And to solve an equation means to find all solutions of the equation. Here, unless stated as angle measured in degree, we mean solution of the equation that are real numbers, or equivalently angles measured in radian. Okay, let's proceed to solving example 3.8.2. We are going to solve the equation 2 cosine minus 1. In order to do this one, we have to solve for the value of x. So we have 2 cosine x minus 1 is equal to 0. To find x, we need to eliminate first the negative 1 by adding both sides by positive 1. That's why we can now have 2 cosine x is equal to 1. Dividing both sides by 2, so that's why we can now have cosine as 1/2. So we are going to find asa dapit ni quadrant or unsa ang value sa x, wherein when we say cosine of x is equal to 1/2. We are to recall there are two situations wherein the values are positive ang cosine. We have in quadrant 1 and quadrant 2. So in quadrant 1, 1/2 ang atong cosine sa pi over 3. O in quadrant 4, 1/2 po atong cosine sa 1, 2, 3, 4, 5. So 5 pi over 3. So meaning, that's why we can conclude that x could be equal to pi over 3 plus 2k pi. Ito pa, wherein k is an integer. Ito pa, pwedeng ang k bisa unsa nga number. Kada igo gyapon na diha no kay 2k man ang usa ka evaluation, times mo 3 bisa 2k, 4k, 5k, 6k, and so on. Okay, another solution is x equals 5 pi over 3 plus 2k pi, wherein k is in the set of all integers. So, ang dire, kung ano na mag 2k, ang kapila sa libot, maora gihapon ang solution rin. Tapos, in x equals 1/2. Okay? So, any concern? Let's proceed to 3.8.3. We solve quantity 1 plus cosine theta times quantity tangent theta minus 1 plus 0. So in order to do this, we are going to use the zero factor law. That means when a, b is equal to 0, this means that a equals 0 or b is equal to 0. So since the two quantities multiplied are equal to 0, that means either this one is equal to 0 or this one will be equal to 0. So that is 1 plus cosine theta is equal to 0. So that's why cosine theta is equal to negative 1. And or tangent theta minus 1 is equal to 0. So tangent theta is equal to 1. So in this case, theta here is equal to, asa man dapit ang cosine theta equals negative 1. Cosine is negative 1 and pi, diba? So pi, so that's why pi plus 2k pi, wherein k is in the set of all integers. Whereas in here, tangent no 1 na asa pi over 4. No? Pi over 4. So therefore, theta would be equal to pi over 4 plus k pi. Anong k pi raman? Naman tuto. Kay tangent man. So, kuha raman ka cases na tangent na. Okay? Wherein your k is any integer. Okay, next is example 3.8.4. Find all values of x in the interval, close interval, negative 2 pi, positive 2 pi, from negative 2 pi to positive 2 pi, that satisfy the equation quantity sine x minus 1 times quantity sine x plus 1 equals 0. So by using the zero factor law, sine x minus 1 equals 0 or sine x plus 1 equals 0. So from here, sine x equals 1 or sine x equals negative 1. So, asa man nga part, sine x equals 1. So, sine is 1 at to sa pi over 2. And in here, sine x squared is sa 3 pi over 2. Or pwede po kag negative 3 pi over 2 here, or kare po negative pi over 2. So, kay negative man, given man nga, negative 2 pi o 2 pi. So, that's why pwede na siya itong ano na. O negative 3 pi over 2. Ang usa, negative pi over 2. Okay, so there are four solutions. So we have positive negative pi over 2 and positive negative 3 pi over 2. Okay. Okay, next is example 3.8.6. We are going to solve that 3 tangent of theta plus 5 is equal to 0. So to solve this one, we have to solve for tangent theta. So 3 tangent theta is equal to negative 5. So tangent theta is equal to negative 5 over 3. Therefore, we can say that theta is the inverse function of tangent of negative 5 over 3. Then, plus k pi, wherein k is in the set of all integer. Okay? So, muna pi, rajud na basta tangent of given. Okay. Okay, next is example 3.8.7. The voltage V involved coming from an electricity distributing company is fluctuating according to the function V of t is equal to 200 plus 170 sine of 120 pi times p at time t in seconds. Number 1, we are going to determine the first time it takes to reach 300 volts. And number 2, for what values of t does the voltage reach its maximum value? For number 1, we are going to solve the V of t, which is 200 plus 170 sine of 120 pi times t is equal to V is 300. Okay, solving the value of t, we can now have 170 sine of 120 pi t is equal to 100. Subtracting both sides by 200. Then divided both sides by 170. So we now have sine of 120 pi t is equal to 100 over 170. And 120 pi t is equal to the inverse function of sine of 100 over 170. And then dividing both sides by 120 pi, t therefore is the inverse function of sine of 100 over 170 all over 120 pi. Okay, using your calculator, the answer would be approximately, t is approximately 0.00167 seconds. Okay. Number 2 is for what values of t does the voltage reach its maximum value. So the maximum value of t happens when and only when the maximum value of sine of 120 pi t is equal to 1. So that's why sine of 120 pi t is equal to 1. So 120 pi t equals the inverse function of sine of 1. And asa man ang sine, asa may value sa theta na ang sine niya is 1. Asa man nagapit. So it's in pi over 2, diba? So it will be the same as 120 pi t is equal to pi over 2 plus 2k pi, wherein k is an element of an integer. And then to solve for the t, we are going to divide this one by 120 pi. So it becomes pi over 2 plus 2k pi all over 120 pi. Because every term has pi, we need to eliminate it. So therefore, t is equal to 1/2 plus 2k all over 120. Dividing 120 by 1/2 by 120, so t is equal to 0.00417 plus 2 divided by 120 is equal to 0.017k. Okay, so that's why it means that the voltage is maximum when t is approximately equal to 0.00417 plus 0.017k. Okay, let's proceed now to equations with two or more terms. We will now consider a group of equations having multi-step techniques in finding their solution. Compiled with the straightforward techniques learned in the preceding discussions, there are more advanced techniques involve factoring of expressions and trigonometric identities. The primary goal is to reduce a given equation into equivalent one-term equation. Okay, so for example, 3.8.8. We are going to solve 2 cosine x tangent x is equal to 2 cosine x. Okay, first thing to do is to just to add both sides with negative 2 cosine x. So the left side becomes 2 cosine x tangent x minus 2 cosine x equals 0. So notice that kanina term, it has a common factor 2 cosine x. Dividing this one with a common factor, it becomes tangent x, and negative 2 cosine x divided by 2 cosine x equals negative 1 equals 0. So using the zero factor law, we can say that 2 cosine x equals 0, or tangent x minus 1 equals 0. So cosine x here is equal to 0, and in here tangent x equals positive 1. So if we are going to analyze, when cosine x equals 0, x there is equal to cosine equals 0, cosine x equals 0. So 0 on cosine at pi over 2, right? pi over 2, so plus 2k pi, wherein k is an element of the integer. Another one is cosine x plus 0 at 3 pi over 2 plus 2k pi, wherein k is an element of the set of integers. Then we have tangent x equals 1. Tangent is 1 at pi over 4. So x equals pi over 4 plus k pi, wherein k is an element of the set of integers. Okay, so more solution for 3.8.8. Okay, what about 3.8.9? We are going to solve for x, which is an element of the interval, half closed interval on the left from 0 to 2 pi. Sine 2x equals sine x. So we have here sine 2x is equal to sine x. Okay, then transposing this one to the left side, sine 2x minus sine x is equal to 0. So we cannot use factoring yet because they do not have the same value of theta. Ang kanin siya kay 2x pa man, the x ni. So we need to give first the equivalent for sine of 2x. So equivalent identity. So using the sine double angle identity, sine 2x is the same as 2 cosine x sine x, right? Minus sine x equals 0. The common factor here is sine x. So taking out that sine x, so it becomes 2 cosine x minus 1 equals 0. So from there, we are going to use the factor law, 0 factor law. So sine x equals 0 or 2 cosine x minus 1 equals 0. So in this case, asaman 0 say yung value sa x in sine x is 0. So x here is 0 or x is pi. Tapos 0 sa pi ang sign. And they belong sa imong kanang domain, right? So that's why mauni si Jack for this. And the second one, the second factor, we have 2 cosine x equals 1. So cosine x equals 1/2. So sa nga part ng cosine is 1/2. Positive ang cosine. So it's in quadrant 4 and quadrant 1. So cosine is 1/2 na asa pi over 3. So x here is pi over 3. And the other one is 5 pi over 3. Okay, so therefore the solution would be 0 pi over 3 and 5 pi over 3. Okay, then we have the tips in solving trigonometric equations. Number 1, if the equation contains only one trigonometric term, isolate that term and solve for the variable. Second, if the equation is in quadratic form, we may use factoring, finding square roots, or quadratic formula. rewrite the equation to have 0 on one side and then factor appropriately. Factor, if appropriate, the expression on the other side. If the equation contains more than one trigonometric function, try to express everything in terms of one trigonometric function. Here, identities are useful. Half or multiple angles are present, express them in terms of a trigonometric expression of a single angle, except when all angles involved have the same multiplicity, wherein in the case retain the angle. Half angle and double angle identities are useful in simplification. So that's why very important tong different formulas nga pang learn from the previous lessons that we have. What ka mao adto mag-result ang answer, diba? Okay, so let's proceed to 3.8.10. Solve for x, which is an element of the half closed interval from the left from 0 to 2 pi. We have 2 cosine squared x equals 1 plus sine x. Okay, so what are we going to do is first, we are going to add both sides with 1 plus sine x. That's why the equation becomes 2 cosine squared x minus 1 minus sine x equals 0. And then since now may sine x there no, so we need to convert this 1 in terms of sine. So 2 quantity 1 minus sine squared x minus 1 minus sine x equals 0. Then distributing 2 to every term inside, we have 2 minus 2 sine squared x minus 1 minus sine x equals 0. Okay, combining 2 and 1, we can now have negative 2 sine squared x minus sine x plus 1 equals 0. Making this the first term positive, we need to divide everything by negative 1. So it is now equal to 2 sine squared x plus sine x minus 1 equals 0. So from there, we need to factor out. Pinamdum po ba mas factoring? Okay, equals 0. So factor this one as 2 sine x. And then this is sine x. Then, dapat maka-answer take positive 1. So, ari na to ang positive 1 and this is negative 1. So that 2 sine x times sine x equals 2 sine squared x. Negative 1 and positive 1 is negative 1. Then the middle would be kanini negative sine x. And this one is 2 sine x. And that gives us positive sine x. Okay. So from there, you are going to apply the zero factor law. We have 2 sine x minus 1 equals 0, or we have sine x plus 1 equals 0. So in this case, 2 sine x equals 1. So sine x is 1/2. So x is, what is the value of x when sine x is 1/2? Sine x is 1/2. So it's pi over 6. Ito ba ko? Pi over 6 and 1/2. There is a pikas. 3, 4, 5 pi over 6. No? 5 pi over 6. Okay? And the reciprocas, we have sine x equals negative 1. Kasi value sa x, ang sine of x is negative 1. Sine is negative 1 na sa ubos, therefore it's 3 pi over 2. So that's why we can conclude that the solution is pi over 6 or r, 5 pi over 6, 3 pi over 2. Okay. Okay, next is 3.8.11. We are going to solve for the value of x, wherein the x is in the half closed interval on the left from 0 to 2 pi. In the equation, 3 cosine x cosine squared x plus 2 sine x equals positive 2. Okay, so in this case, we have sine squared x plus 5 cosine squared pi over 2. Okay, we do x over 2 is equal to 2. Wait, is how many na kung we are number 11 pa. Sorry. Number 11 pa tayo. Ang unan po. Okay. Number 11 di ay 3 cosine squared x plus 2 sine x equals positive 2. Okay, so the first thing to do is to convert this one para magpapareha silang sign, di ba? So no need, we cannot convert man sine x to cosine, but ang cosine squared ma-converted na nato. So that's why si Jamaya pang i-change. So 3 and then cosine squared is 1 minus sine squared x plus 2 sine x minus 2, adding both sides with negative 2. And then simplifying, we have 3 times 1 is 3 minus 3 sine squared x plus 2 sine x minus 2 equals 0. So in this case, we can now have 3 sine squared x plus 2 sine x plus 1 equals 0, making this one positive. So divide and both everything by negative 1. So this becomes negative. And 1 is also negative equals 0. Okay. Factoring. We have 3 sine and then sine. Then negative 1 here, and this is positive 1, so that negative 3x plus sine x equals 0. Okay, so in this case, we can now have 3 sine x plus 1 equals 0, and the other one is 4 sine x minus 1 equals 0. So sine x therefore is positive 1, and in here 3 sine x equals negative 1, so therefore sine x equals negative 1 over 3. Okay, for negative sine x equals negative 1 over 3, there is no such answer in the special circular functions, diba? So x would be equal to the inverse function of negative 1/3. Then this would be equal to, or plus na to 2 pi. Okay, or pwede po siya of x is equal to pi minus a sine of negative 1 of negative 1/3. Okay, then sa second part, we have sine x plus 1. So your x there, 1 na sine is naa sa pi over 2. Two plus 2k pi, or rinaan naman data rinaan naman ito na from 0 to 2 pi naman. So therefore, it's pi over 2. No need to add. Okay, so ang atong answer would be pi over 2, then this one, and this one. Okay, next is example 3.8.12. We are going to solve sine squared x plus 5 cosine squared x over 2 equals 2. So we have sine squared x plus 5 cosine squared of pi x over 2 equals 2. Okay, so what are we going to do is i-replace din nato sa half angle kaya naman tayo value, no? Cosine man to siya, so ato siyang i-replace. So we have basta po ning sine squared aron makosine sila tanan kay yung ganin hindi man nato siya mahimo na cosine. Okay. So, sine squared is mahimo nato na 1 minus cosine, diba? 1 minus cosine squared. Ano? Then, plus nato sa 5 ang cosine squared of x over 2 can be replaced with 1 plus cosine x over 2 equals 2. Okay? To eliminate these 2 in the denominator, we need to multiply everything by 2. So, it becomes 2 quantity 1 minus cosine squared x plus makancel ang 2, it becomes 5 quantity 1 plus cosine x, and this will becomes 4. Okay, then distributing 2 times 1 is 2 minus 2 cosine squared x plus 5 times 1 is 5 plus 5 cosine x equals 4. Okay, combining everything, so it becomes a negative 2 cosine squared x plus 5 cosine x. This is 7. 2 plus 5 is 7 minus 4 is positive 3 equals 0. Then making the first term positive, or the x squared term, the squared term becomes positive. So 2 cosine squared x minus 5 cosine x minus 3 equals 0. So factoring, so this is 2 cosine x, and this is cosine x minus 3 plus 1. So that we have negative 6 plus 1 equals 0. So 2 cosine x plus 1 equals 0. It becomes 2 cosine x equals negative 1. So cosine x equals negative 1/2. Asa nga part ng negative 1/2? So x equals negative 1/2 na sa quadrant 2 ang x o quadrant 3. Quadrant 2 and quadrant 3. So therefore, dito ang 2 pi over 3 plus 2k pi. And another one is ubos. In quadrant 3, we have 4 pi over 3. Diba? Plus 2k pi, wherein k is an element of the set of integer. And then sa dere, cosine or maninaw, cosine x equals positive 3. So notice that wa man mahitabo na i-value yung cosine. So therefore, x is empty or it has no solution. Okay, number 3.8.13. We are going to solve for x is an element of the half-closed interval on the left from 0 to 2 pi in the equation tangent to x minus 2 cosine x equals 0. Okay, so what are we going to do is, given is tangent to x minus 2 cosine x equals 0. So, kaya man sila kapareha, so we need to express tangent in terms of sine and cosine. So, it becomes sine 2x over cosine 2x minus 2 cosine x equals 0. To eliminate the cosine 2x, we need to multiply each term by cosine 2x. So if we are going to multiply this one by cosine 2x, what will be the answer is sine x minus times into cosine 2x. So 2 cosine x cosine 2x equals 0. Okay, after that, we are going to replace this one with the value nga mahimo sa diyang sine. So, sine x minus 2 cosine x times 1 minus 2 sine squared x. O ba? Equals 0. So, simplifying, we are going to simplify. Kahit ano pa, kaya mag 2x dire. Nawa na ang 2x. X na lamang. Okay. Really sine 2x na. Okay. This sine 2x can be substituted with 2 cosine x sine x minus 2 cosine x. When we multiply this one times 1 and this one times this one, it becomes positive 2 cosine x sine squared x equals 0. Okay? Factoring the 2 cosine, paggawa sa 2 cosine x, what is left here is sine x minus 2, minus 1 na lamang yan. Minus 1 plus sine squared. equals 0. So arranging the terms here so that it will be easier for us to factor out 2 cosine x quantity sine squared x plus sine x minus 1 uy, time pa. 4 na di ay no. Pakadali. Balik tagamay. Balik tagamay ha. This one times this one is equal to positive 4 cosine sine squared. So, we factor out ang 2 na apa ni positive 2 sine squared. So, positive 2 ni plus sine x minus 1 equals 0. Okay? Using the factoring na po ni siya, so it will be 2 cosine x quantity 2 sine x, the sine x dire, plus 1, I know, minus 1. Sine x minus 1 plus 1 equals 0. So the factor for this, the factors are quantity 2 sine x minus 1 times quantity sine x plus 1. So there are 3 factors that would be equal to 0. So the first one is 2 cosine x equals 0, or 2 sine x minus 1 equals 0, or sine x plus 1 equals 0. So in this case, cosine x equals 0. Ang imong x diha, cosine x equals 0 na asa pi over 2 o 3 pi over 2. So, and then in here we have 2 sine x equals 1. So sine x equals 1/2. So asa man dapit ang 1/2 nga positive. Sine 1/2 is positive. Sine 1/2. So your x there is sine 1/2 is pi over 6, and bang sa pi over 6 is we have 5 pi over 6. Okay, positive man sa quadrant 2, diba? Kaning 5 pi over 6. Then, dere, sine x equals negative 1. So, asa nga part nga negative 1? Sine x. Pila value sa x? X equals 3 pi over 2. Okay? So, therefore, ang values, we have 4. Okay, kaduha naman ang 3 pi over 2. So, pi over 2, 3 pi over 2, pi over 6, pi over 6. Dili na kadaho ang kaduhaon. So, what ang kanang 3 pi over 2. Okay? So, ana ra. So, I think ang kantong sa more solved examples, more magsampan more understandable na. So, din hira lamang tapotog ha, kamo na nakay basa in a way, wako po makatan mo dyan o grabbing activity for this, kay 1 week or atong natin gihatag na time. So, that's all for today. Thank you for listening, and we hope na mag-uban pa ta sa basic calculus sa next semester. Good luck, guys. Bye-bye. Thank you.